All right, so welcome back. We're going to continue with Java today. Remember that there is no class on Monday because of Martin Luther King Day. We left off last time with talking about interactive input, where you can use a scanner to scan the standard input. Remember that the standard input is your keyboard. And then you can prompt for input, and then you can read an integer. You could read a double. You could read just next is the next string. So if you wanted to read in like a name or something like that, you could do that. But of course, we're not going to use this because most computing is not interactive. Most computing is done so that one computer can talk to another computer, or one program can talk to another program. So the way that we're going to do it is through command line arguments. Let me come over here, right? Or CLAs for short. That's non-interactive input, where you provide things when you start the program. You provide the input as part of the input to the program. That is where args comes in. This is supported in every single programming language. If you're coming from a C background, you know argc, the argument count, and argv, the vector of the arguments. If you're coming from a Python background, if you bring in the system library, sys.argv is the same thing. So what we're going to do is we're going to start working with this. First of all, how many arguments are there? I'll call it num_args, right? This is, you actually have to ask the arguments here because it's an array. We'll talk about arrays later on, but the syntax for arrays is like this. Is like this. It's an array of strings. So what we need to do is we need to ask it how many there are. Args.length will tell us that, right? That's the number of arguments. And then we can print this out, system.out.println num_args, right? Well, I'm just going to go ahead and run this as is, and we're going to see that the number of arguments is 0 because I didn't actually provide any command line arguments. If I were at the command line executing this as a program, then I could type those out. But we're in an IDE, an integrated development environment. So what we need to do is we need to specify those as part of our run configuration. So instead of the play button, I'm going to hit that little arrow right next to it, come down to run configurations, and you probably did this in your lab on Wednesday. But then you go over to arguments, and then you can provide whatever arguments you want, 10, 20, hello, right? You can apply that or just run it, right? There we go. And now we've got 3 command line arguments. Those coming from either a C or Java or a Python background, this is going to be a little bit different. Because the first command line argument in both of those languages is the executable file name or the executable script name. In this case, we don't have that because we know what the executable file name is. It's called demo, right? We wrote it, right? And it's not going to change when you actually run this program. So that's the number of command line arguments. Now, how do we actually convert them? All right? So if I'm expecting the first command line argument to be an integer, what I can do is I can create int x, right? And then I can say integer.parseInt, right? And then the first command line argument is in args of 0. So it's 0 indexing, just like Python, just like a C, right? The first one is at index 0. If I'm expecting the second one to be a double y is equal to double.parseDouble, right? And arg sub 1, right? If I'm expecting it to be a string, then there is no conversion necessary. I can just go ahead and say string foo is equal to arg sub 2, right? That's going to be the third command line argument. And then we can all print them out, right? Remember that there are several ways to print stuff. System.out.println, print, and printf. Let's get more practice with printf. System.out.printf, right? Now I want to print each one of those things. X is equal to, what is the placeholder for integers? Do you remember? %d for digits, right? And if I want to say y is equal to, and if I want to print out that, it's a floating point number, so it is %f for a floating point number. Now if I wanted to do a string, foo is equal to %, this one makes sense as well, it's %s, the string. And then of course you can end the line there. The arguments that I'm going to provide here are x, y, and foo. The same order that your placeholders here are, that has to follow the same order of your arguments over here. Right? So let's run this and see if it works. Oops, there's a, all right, fine. There's a compilation error, and so that's why we're going to get a bunch of red there. Oh, what did I forget at the end? A semicolon. That was it. All right, and you know what? Let me give myself some more real estate here. Let's move this over. There we go. All right. and there. 10, 20.00000 because that's the default, and then finally hello. What do you think would happen if I gave it something that was not an integer for that first argument? What if instead of 10, I said ten, or ten, there we go. Now, is that going to be convertible to an integer? Nope. So what happens here? In C, it probably would have just said, okay, t, that's not a number. I'm going to stop. What have I parsed so far? 0, and so it ended up with 0. It's completely different here, right? It's going to be an exception. We'll learn very quickly that this red stuff means an error. Exceptions are errors, right? The number format exception is what we have here for the input string ten. It ends up being a fatal exception because this print statement actually never gets executed. What happens is an error is thrown up here on line 12 or 13. It is not caught and handled, and so the program dies at that point. We'll talk about how to use exceptions, how to throw exceptions, how to handle them later on. But otherwise, for now, know that if you've got a red wall of text here, it means that something went wrong. And by the way, the convenience of an IDE here, you can go ahead and click on things to find out where the exception occurred. It says demo.java line 13 is what that colon 13 stands for. And if you click on it, it'll take you right to that line and you can start debugging. Okay? All right, so those are command line arguments. And you also got exposure to them in your lab yesterday, I believe. And you'll be using them partially for your first assignment as well as for the first exercise and the last exercise. All right? There it is in the notes for you. All right, those are the basics. Now we can move on to conditionals, right? So just as with both languages, you need to make decisions, right? Java has the traditional if, else if, else, or if else, and if else if statements, right? And this is going to be a little bit different syntax for those of you coming from a Java or from a Python background, but for those coming from a C background, it's virtually the exact same syntax. So for example, the other day, the Husker score, I think it was 90, right? In basketball, and they played Oregon and blew them out, and their score was, I believe, 55, right? So who won, right? Let's go ahead and ask who won. Or let's go ahead and set up a conditional for who won. If the Husker score is strictly greater than the Oregon score, right, then that means that the Huskers won. So let's go ahead and system.out.println Huskers win. Right? Yay. Now look at the syntax here for those coming from a Python background especially. There is a beginning parenthesis and an ending parenthesis here. And then we use brackets to denote code blocks. Anything in this code, within the opening bracket and the closing bracket, that is bound to this if statement, right? And so right now, if I just run this, of course, the Huskers won, so it will print out Huskers win, right? You can also add an else statement here, right? And another code block with curly brackets here. Note also the style here, the beginning curly bracket begins on the same line as the if statement. The closing one is aligned vertically with the I in the if statement. Anything else is not the way to do it in Java, right? There are some other style guides out there for C. There are style guides for Python, but if you get the spacing wrong on Python, then it won't even run, right? But let's go ahead and put an else here. System.out.println Oregon won. Oregon. That's how you spell it, right? Oregon wins. Is what? Oregon? Is it? All right. Fine. There we go. And I'll leave the variable right like that for now, and I'll show you another trick. I think I showed it to you before, but we'll review it. Let's go ahead and swap the scores here. What if it was 55 and 90, right? Now what would happen? Oregon wins. These are mutually exclusive, just like any other programming language. Exactly one of these will execute. But that's not the only possibility, right? What else could happen? What if after the second half, we were both at 90? Does anybody win there? No, that's called a tie. Right? So let's make it more explicit on this else condition. If the Husker score is less than the Oregon score, Oregon score, right? Then that means that Oregon wins. But the only other condition here is what? If they're both equal, and you don't have to check for that because it's either strictly greater than, strictly less than, or they're equal. But otherwise, if they're equal, then system.out.println tie. Right? Go to overtime. There we go. So let's see if that works now. And there, it's a tie. Right? Again, these three things are mutually exclusive. Exactly one of these three, line 13, line 15, or line 17, one of them will execute, and only one of them will execute. Okay? Now let's go ahead and fix that Oregon spelling. Right? Remember the trick I showed you before? If you right-click something and refactor, rename, and you said that it was Oregon, there we go. There. It changed it in all the locations for me. Right? So if you misspell something, that's fine. Just go back and fix it at some point. Right? Now let's go and let's restore the actual score here before we put this into the notes. But there is a basic if, else if, and else statement. The else is always going to be optional. The else if is always going to be optional. You can just have an if it's do something or don't do something. And this is the same in any programming language. So if you already have a good familiarity with logic in Python or Java or C, then you're good to go here, right? Just the syntax is a little bit different. We have numerical comparison operators, right? For example, less than, or strictly less than or equal to, greater than or equal to, not equals, and then equals for strict equality there, right? These are only, let me go ahead and go in indent here. These are only for numbers, never strings, right? In fact, it won't even compile if you try to do this with strings. For example, let's go ahead and string A is equal to apple. There we go. And string B is equal to banana. All right. Let's go ahead and try to make a numerical comparison operator between these two. If A is greater than B, then system.out. It doesn't even matter what I print down here because it won't even compile on line 12, will it? Println foo, right? Right? It's not going to let you even do this. Now, unfortunately, it will allow you to do something like this, right? But it's not looking at the contents of those memory locations, or it's looking at the memory locations, not the contents of those memory locations. Let me show you that it will not work. For example, if I go new string apple, right? Those two strings are the same, right? They're both capital A apple, but it will not print out foo, I believe, in this case, because I forced it not to. System.out.println bar. So you would expect it to print out foo because those strings are equal, but that's not how you do it with strings, right? It prints out bar instead. They're not equal, even though they have the same contents, apple and apple. I'll talk about how to do this in a second here, but otherwise these are never for strings, okay? Even the equals, not equals, they still will not work, right? Let's see. Another difference. Java has Boolean variables. In fact, I'll go ahead and highlight that. Right? There we go. C doesn't have Boolean variables. Python does have Boolean variables, but it's a little bit different syntax here. We have to actually declare them. Boolean, like say is student, right? And then we can set this to true or false. False, right? Later on, I can say is student is equal to true. So the difference there is that it's all lowercase and it is case sensitive. You can see that it's highlighted in purple here. They are reserved words, right? It's not uppercase F, uppercase T like it is in Python. You don't have to bring in another library like you do in C. Instead, it is built directly into the language. Okay. So and then to use this, of course, you could just use the Boolean. Just use the operator. Don't do this. If is student is equal to true, then I'll go ahead and give them a discount. System.out.println basketball ticket discount. Yay, because you're a student, right? Is that true, by the way? Probably not anymore now that they're good, right? But anyway, you don't do this, right? They are a student. I set it equal to student, so it should print out basketball discounts, right? But that's not how you should do it. Instead, you should just use the variable. There's the better way of doing it. Okay? Just use the variable. Don't say, is this variable equal to something? Okay? Java does have Boolean variables. Let's see, here's our example that I just did. Right? I don't know why it's, come on. There we go. Now it all aligns. Okay. All right. Let's see. What about Boolean operators, right? Logical and, or, not, etc. Right? Well, the logical and is going to be done through ampersand, ampersand. That's the old school way of doing it. If you're coming from a Python background, this is going to be a little bit different. Instead of using the keyword and, you're going to be using ampersand, ampersand here. Most programming languages do it like that, right? C does it like that, for example. There's the logical or operator, and this is going to be two vertical lines. Sometimes in math, these are called Sheffer strokes. In computer science, sometimes we call them pipes. You can call them vertical lines, and there's always two of them. Not one, because if you use one, it has a different meaning, and it's a bitwise and operator or a bitwise or operator, which we're not really going to cover here, right? Once again, it's not. Come on. All right. Nope. Nope. All right. I don't know why it's not aligning, but whatever. We'll try it like this. Okay. All right. And then there's the logical negation, which is going to be a exclamation point. You can take any expression and you can put an exclamation point in front of it to negate it, right? So for example, let's just go ahead and say, if they are a student and their age is less than 21, basketball discounts, but no beer. All right, there we go. And let's go ahead and create that variable here, int age, and we'll say that they're 18, right? Okay, so is that going to print? Are both of those logical conditions true? They are a student. I set that equal to true on line 19, but they're 18. They don't get any beer, right? There we go. But if I wanted to, I could negate this. Now, if I put the negation here, does that negate the entire statement? Nope, it only negates the Boolean variable is student. So I have to use parentheses if I want the entire thing to be negated, right? And let's go ahead and run that. And now they don't get their discount and they don't get their beer, right? That could mean that they are not a student or they're not 21 and over, right? So think about your logic here. And usually you don't put I don't know why I put a space there, but there you go. Space should go there, right? All right. Here's another example that I'll put in the notes for you. Right. Any questions so far on conditionals? Otherwise, we're keeping it really simple here, right? One more exercise here. Right? This is the classic one I always do. Let's go with double A is equal to 10, double B is equal to 20, double C is equal to 30. Now, if those are the coefficients in a quadratic equation, right? A, B, and C, how would you compute the roots? Double root 1 would be equal to, what is the quadratic equation? You got that memorized, right? You got that drilled into you, hopefully, at some point. Right? No? All right, negative B, plus minus. Can I do plus minus, though, in code? No. Square root. All right, how do we do square root? We need to bring in the math library, dot square root. Remember that from last time. And what are you taking the square root of? B squared minus 4AC. Right? That's all wrong. First of all, this compiles. What does that caret mean, though? That's a bitwise exclusive OR operator. It doesn't mean what you think it means. So how do I go with a power? How do I go B raised to a power? If you're coming from a Python background, yeah, you could do that in Python. You can't do that in Java. Right? So how do I raise B to the second power? Yeah. Math.pow, exactly. Right. And then we're raising B here, B to the power 2. You could do it like that. Of course, if it's just power 2, just go ahead and B times B, right? B squared. But if you have a power like 2, raise it to the 2.5 or something, right? then you would need to use math.pow. Everything, sine, square root, cosine, all that stuff can be found in the math library. It does not need to be imported like the scanner needed to be imported because it's part of the language. It's actually part of the java.lang package, which is by default brought in anyway. Right? For AC, can I do it like that? Nope. I have to actually explicitly multiply. For AC. There we go. Now, what's at the bottom? What's in the denominator here? All over, isn't it 2a? 2a, 2 times a. Maybe we don't memorize it anymore. Do we remember? Hopefully we do. Right? It's just one of those things. Right? All right, so is that going to work? Is my logic correct there? Yeah, everything in the numerator, that guy on the top, has to be in the numerator, right? Otherwise, what I was doing there, oops, too many, right? Otherwise, what I was doing is I was leaving out the b part, and I was just dividing the radical over here by 2a, right? So that should work. Copy, paste. Avoid copy pasta as much as possible, but in this case, it's probably okay. Because what's the second root? Minus. Right, there we go. Okay? And system.out.println, the roots are going to be, and then here I'll just concatenate it, plus root 1, and then comma plus root 2. All right, great. What if I had screwed up the entire time and, that one's not indented correctly, that one's not indented correctly, maybe one's not indented correctly, that one's not indented correctly, et cetera, right? You'd have to go through and fix this and clean it up right? Or you could just go ahead and use your IDE to your advantage and let it do it for you. At least on a Mac, it's going to be Shift-Command-F, and it formats everything in a nice in the default format. Oops, I'll show you that here in a sec. I don't know why it did it automatically on that, but in fact, I think it probably put white space over here as well. Let's see if it does that. Does it like more white space? Yeah. All right. It uses the default Java styling to do everything for you. And again, that's Shift Command F on a Mac. I'm sure that on Windows it's going to be Shift Alt F or maybe Shift Control F. Go ahead and play around with it and see which one it is. But you can always go ahead and fix things so that they're nice and indented and everything is consistent. We do grade based on consistency. Small number of points. You should get into the habit of writing good code anyway, but make sure that it's fixed before you hand it in. Okay. All right, does this work though? Let's find out. Nan. What's a nan? Not a number. Why? Think about b squared. That's 400 minus 4 times a times c. That's going to be more than 400, right? So what ends up happening here? You're taking the square root of a negative number, right? Which is a complex number, which as far as code is concerned, is not a number, right? Likewise, what if I were to divide by 0? Double x is equal to a divided by 0, right? What's going to happen there? And by the way, this was not an error. Nan was just the result of it. We don't have a bunch of red text here telling us that this is an error, this is an exception. But now, come on, probably system.out.println x. There. Let's find out what x is now. It's infinity, right? Weird, but that's also not a number. By the way, what if I multiplied x by 5? Would it be 5 infinity? No, infinity is infinity. What if I subtracted infinity? It'd still be infinity, probably. I don't know. We'd have to figure that out. But now this allows us to check for these things because we have conditionals, right? If that radical, that b squared minus 4ac is going to be 0, in other words, b times b is minus 4ac is less than 0, then I can handle that a little bit differently. System.out.println, I cannot handle complex roots. Or maybe you can, and you just have to code it a little bit more. Otherwise, I'll go ahead and print out that, sorry, everything's on a delay because I've had to use a screencast here. So it's all choppy. Right, there we go. I can't handle complex roots. Let's go ahead and fix it so we can handle complex roots. Let's just go ahead and make c smaller, right? There we go. And there are the roots, okay? So negative values there. But otherwise, what happens when bad math occurs? You've got this. What's another piece of bad math could happen? X is equal to, I don't know, math.log. What can't you take the log of? Okay, negative. I was just thinking 0, right? What's that going to be? What happens? What does a graph of log look like? It's a very slow-growing function, but what happens at 0? It goes down to negative infinity, right? So weird stuff happens when you have bad math, and it's not necessarily an error. It's not going to throw an exception with a red-green or a red text. Instead, more examples. Right? Instead, it's just going to result in not a number or infinity. Right? At that point, the game is up, though, because not a number plus 5 is still not a number. Okay. All right. Any questions on conditionals? No? All right. Then let's talk about loops, the other thing that I was going to do today. Right? So Java has for loops, while loops. It also has do while loops, but I'm not even going to bother with them. Right? Java also has what are called enhanced for loops. You'll understand these as for each loops. Right? So this is going to get some used to for those coming from a Python background, because Python doesn't actually have for loops. They have for each loops that are bound to an iterable structure that, like for x in range of whatever you want. We have similar syntax though, and those coming from a C background, it's exactly the same syntax. So for example, let's go ahead and create a variable here called n, and I want to count up to 10. Right? For int I equals 0, that's what's called my iterator variable or my index variable. I is less than n, I plus plus. Right? Now there are 3 parts to this. This is the initialization. This is where I will start at 0. This is the continuation condition. While I is strictly less than n, this function, this for loop will continue to execute. And then I plus plus, what that does is that adds 1 on each iteration of the loop at the end of the loop. So let me go ahead and system.out.println I, and I'll fix that. System. There we go. All right, so predict. What is this going to print? What is the first thing that it's going to print? I starts out at 0, so it's going to print 0. What's the last thing that it's going to print? It's going to print out 9, right? Because 9 is strictly less than 10. But will it end up printing 10? Is 10 strictly less than 10? No. So it ends up stopping at 9. Right? I could, of course, change this. If you want to go up to and include n, then you can do that. Right? There we go. That'll go from 0 to 10. But usually this is what's called the idiomatic for loop. I starts at 0, it goes up to, but does not include the last number, and then it goes up by 1s. That's the default idiomatic for loop. That's exactly the same as if you had done this in Python and done for I in range of n, in this case, right? And then you printed it out. Range will do exactly what this for loop is doing right here. It'll start it at 0, it'll go up to but not include n, and it'll go up in increments of 1. You can always go in different increments, right? You can start it at different values. For example, if I started this at 2, and I went up by increments of, say, 3, right? Plus equals 3, that will add 3 on each iteration of this. So if I start it at 2, it'll print 2. It'll go up by 3, print 5, 8. Will it print 11? Nope, 11 is greater than n. So it'll be 3, 5, 8, right? 3, oh, sorry, I said 2, 2, 5, 8. There we go, because it starts out at 2, right? And again, you can change one of these conditions here. What would happen here if I tried to print out the last value after the loop? Print ln I. So there's a red line under I, and if I highlight it, it'll tell me what's wrong with it. I cannot be resolved to a variable. It has no idea what I is. Why does it have no idea what I is? By using this syntax, I've only declared it for this particular loop, right? That means that this variable, it gets born on line 10, but it dies on line 12. It goes out of scope. That's what you want to do with your loops. Unfortunately, with a while loop, you're not able to do that. With a while loop, you have to actually declare it before you start. I'll say I'll start I at 0, while I is less than n, right? Oops. There we go. System.out.println I. Right? Now I've got my initialization condition right here. If I were to print that after the loop, now that compiles because it's been declared on line 18. It dies at line 24, right? On line 24 right there, right? And so it does live on line 22. Okay. Now I've expanded the scope by using this while loop. Walk me through this. What is this going to do? I is going to start at 0. While I is less than n, what does it do? It prints I. Did we change I so far? Nope. So what's going to happen with this loop? 0, 0, 0, 0, 0, 0, 0, over and over and over again. How do you stop this? Well, if you start it with a play button at the top, how do you stop it? With the stop button at the bottom, this red stop button right here. There we go. And you can clear it out. What should I have done here? I plus plus. Right? Now that ensures that it'll go up by increments of 1. Right? But you can change it. If you wanted, you'd use a while loop in any situation in which you want more control on when your iterator or your condition gets updated. For example, up here in the for loop, this plus adding 3, that happens at the end of the loop, always. But what if it's the first thing that you want to happen to the loop? Right? So system.out.println. What I'm doing here is I'm printing a bunch of stuff so that I can see the distinction between all these loops. Now walk me through this. I is going to be 0 at first. I is less than 10. That's true. So we execute this loop. Then we immediately increment I to 1. So what is the first thing that gets printed here? 1. Then we go back up. It gets printed again and again and again. What's the last thing that gets printed with the loop? So 9 is less than 10. That's true, right? What's the first thing that happens? It gets incremented up to 10. So this one will end up printing 1 through 10 instead. There it is. There's the divider that I wrote, that I printed 1 through 10. Okay. What would happen if I restore that after the loop there? Right? How did I get out of the loop? I became greater than or equal to n, right? Well, let's find out. I think it'll just repeat 10, right? Yeah, in this case, right? All right. And then finally we have enhanced for loops, right? You can iterate over an array, a list, set, etc. We'll talk about lists and sets and arrays here next, I guess. But I'm just going to go ahead and give you a preview here. Let me go ahead and create an array of primes. Right? What are the prime numbers? 2, 3, 5, 7, 11, 13, 17. Right? There we go. There is a way of creating an array and then immediately allocating, providing its values. How big is this array, by the way? 1, 2, 3, 4, 5, 6, 7. If this were C, I would have to put this into another variable. I'd have to keep track of the size of this array and say that it's 7. I don't have to do that here. Right? Here's how you can traditionally iterate over this array. For int I equals 0, I is less than the size of the array, I plus plus. Right? Now you can't, that's not actual code. I'll get back to that here in a second. System.out.println, or let's go with printf, right? Prime sub %d is equal to %d, end the line. Right? And what I'll do is I'll print out both the index variable here and prime sub I. Right? That is the ith element in that array. Okay? Now, how do I resolve this? How do I get the size of the array? How did we do it with command line arguments at the beginning of class today? Do you remember? Yeah, it's that what? Let's come up here. Where was it? It's dot length, right? So let's do the same over here. And here, in this case, the name of the array is primes. Let's go ahead and use primes.length. There we go. It's not compiling. I have a duplicate variable now. Remember that I declared I up here on line 19. I cannot now declare a new variable called I that is just scoped to my for loop here. So compromise. I'll go ahead and do this for now. Right. Let's see this in action. It will print out each one of those. That prime sub 0 is 2, 3, 5, 7, all the way up to 17. Right? Remember that it's strictly less than because of 0 indexing. The first one starts at 0, so if there are 7 of them, and you start at 0, 1, 2, 3, 4, 5, 6, the last one is going to be at 6. Right? But an enhanced for loop is way better. For, and those coming from a Python background will recognize this, though not the syntax necessarily. The way that you read this is for each integer, let's go with int, x, in the collection primes, go ahead and print that out, system.out.println x. Right? Now, what I've done here is I've created a variable x that is scoped to this loop and gets automatically updated. For each, again, the way that you read this is for each integer x in the collection primes, ... right? Then go ahead and print out x here. The syntax here is a colon, right? And you do have to provide a name for the variable. That variable gets changed on every single iteration. There's the collection that you're actually iterating over. Let me go ahead and show you this. Save. There we go. All right, and I get a little bit different behavior here because I don't have access to the index variable anymore, right? I'm just printing them out. There is no need to create a variable I here on the for when you're using an enhanced for loop, right? Here's another trick. Let me go ahead and get rid of that for loop now. Right? How did I comment out an entire block? Well, or uncomment out an entire block. Right? All you have to do is select whatever you want, and then and on a Mac it's going to be command /, right? / again to toggle it off. If you're on Windows, I imagine it's Alt or Control instead. Alt? Control, there we go. Control, right? All right. So some IDE tricks here. Most IDEs support these things. It's just that their key bindings are a little bit different, right? All right. And there it's in the notes for you. Okay. That takes us up to basically you've got everything that you need for your lab next week on Wednesday. Remember, there is nothing on Monday. Let's talk a little bit more in depth on arrays before we go, though. Right? Java does have basic arrays. They are 0 indexed, right? In other words, they start at 0, 1, 2, 3, all the way up to n minus or n minus 1, right? And they are of a fixed size once you create them. So here's a very, very, very quick example for another example for doing that. Let's go ahead and go with numbers. Right? Now, if I just did it like that, that's one integer. If you wanted an array of integers, you need to use these square brackets there. Right? Now, at this point, what is the size of that array? There is nothing, right? It's actually null. If I tried to do something with this right now, it's uninitialized and it probably won't even compile. Wonderful, right? The local variable numbers has never been initialized, right? It won't even let me compile and do something like this. Instead, what I need to do is I need to tell Java, create me an array of a certain size, right? Now, if you were doing this in Python, then you don't have to do that, right? That you could just create a list and it'll grow and shrink as you want. And C, you have to call malloc, memory allocation, to actually allocate enough bytes to store however many integers you want. Here, it's kind of in between. Just give me a new integer array of size 10. Okay? You can put that in 10 into a variable if you want. You can read it in from the command line if you want. This doesn't have to be a fixed value. It could be n, right? As long as you've got a variable with that, right? Now I can go ahead and assign a value to it. Numbers of, the last one is going to be n minus 1, right? I'll set that equal to 42. Right? What are the other values, by the way? That is 1, 2, 3, 4, 5, 6, 7, and 8. What are those index values? What are they? In C, do you have a guarantee of what they would be? Nope, it'd be a crapshoot, right? In both Python and Java, however, we do have a default value. The default value is 0. Right? Let me go ahead and show you how to print it. You could write a loop now like we just did to print them all out. Here's an even quicker way of doing it, though. System.out.println numbers. Right? Except that this is not going to work. Right? I'll show you how to make it work, though. What is that gobbledygook? What is that nonsense? Looks like a hexadecimal code to me. That's the memory address of your array. Right? In C, you have pointers where you can actually access directly the memory. You don't have that in Java, but sometimes it leaks information like this. That's the Java virtual machine memory address where that thing is stored. It's not very human-friendly, though, is it? Let's go ahead and make it human-friendly by asking, hey, that arrays class, right? Go ahead and convert that array, that numbers, to a string for me. And it's going to format it in a really, really nicely formatted manner. Right? It's kind of like pretty printing in Python. Have you ever used the pprint library, the pretty printing library? It'll do that. It'll do something like this for you, where it has nice commas and spaces. The last one doesn't have a comma, and then it surrounds it in square brackets there. Right? Super, super nice. Right? But otherwise, I wasn't lying. The rest of them are all zeros. What if you were to do something like this? Number sub 10 is equal to 102. Is that valid? What are the valid indices again? 0 through 9. So what if I try to go beyond that? Well, in C, this might be, undefined behavior. It might be a segmentation fault, a bus error. Right? It could manifest itself in a dozen different ways. Here, there's only one way of manifesting itself, with red death of exception. What kind of an exception is it? An array index out of bounds exception, right? And so that's going to occur if you go too high or too low, right? Is there a negative index? Not in Java. In Python there is. What happens with a negative index? If I've got five things in my list in Python and I go -1, what happens? Maybe you don't know this trick in Python. It goes back around to the last one, right? All right, you can't do that in Java, though. These are both invalid. Numbers of 10 is equal to 102 and that. So these are both invalid. Results in index in an exception. I don't want to write that whole thing out there. Right? All right. There is your primer on arrays. And we're immediately not going to use them, right? So why did I just waste my 10 minutes of time talking about arrays just so that you have something that looks familiar? Instead, we are going to use something that is a whole lot better, right? I know those of you from Python will appreciate this too. We're going to use a list instead, right? And in this particular case, I'm going to use a list of integers, right? And these are my numbers now. New array list. There are several different types of lists. We'll get into that much later in the semester when we actually implement our own lists. But for now, spell integer correctly too, right? For now, we're going to use an array list. It is something that needs to be imported because it's part of the java.util library, just like scanner is. Util is short for utilities, right? So these are the most commonly used utilities, right? By the way, don't leave unused imports in there. Once you're done, if you're not using them, get rid of them because otherwise it results in a warning, okay? All right, there's my numbers now. How big is it? I did initialize this here, but initially it's going to be of size 0. Let's add something to it. Numbers, so dot add 10, right? Numbers dot add 20, right? With an array, when I create an array of size 10, it could only ever be of size 10. It can't grow, it can't shrink. A list can. How big is the list initially? Well, there is no there is no initial capacity. It can hold however many things you put into it. It will grow and shrink automatically as you add stuff to it, as you remove stuff from it. Let me add one more thing here, numbers.add 30. Now, if I were to print this out, system.out.println, first of all, it's much nicer than the array being printed out because I don't have to call a class to do it for me. But there's the order, right? If I were to add one more thing to this, numbers.add, where would it end up being? Where is it adding things by default? At the end, right? Now let's run this. There we go. 10, 20, now 40, right? There are ways that you can add arbitrarily to any numbers.add to index, I don't know, let's go ahead and add it at index 0, and we'll add now 50 to it. Right? There we go. I think that that's the correct order. Let's go ahead and find out. Where is this going to end up adding it now? At the beginning. Because I've actually provided 2 arguments here. Add it at index 0. Add 50 at index 0. It puts it at the front. What if I wanted, like, say, 60 at, I don't know, 60 at 3? Right? Now, here's where it was before. There's index 0, 1, 2, 3. So what's going to happen in this case? It's going to slide everything over and put 50 where it belongs, where I told it to belong, right? Can you do that with an array? No, right? That's why arrays suck, and we're going to use lists almost exclusively, right? There's 60 right there where 30 used to be, but 30 and 40 are still in there. They've just shifted down, right? Can you remove stuff? Absolutely. Numbers dot remove. Right? This is going to be index-based. Yeah. Remove, let's say, 0. There we go. Hopefully this works. Otherwise, let's print it out to make sure that it works. There's a problem when you're using integers. It doesn't know if you're asking, do you want to remove the number 0 that's in your list, or do you want to remove the thing at 0? It gets confused, basically. In this case, it interpreted it correctly. It went with remove 0. In other words, remove that 50. What if I were to remove, I don't know, 0, 1, 2, 2? Right? What's that going to end up removing? That ends up removing that 60 that I put into it, and now we're back to 10, 20, 30, 40. Right? Wonderful. Right? You can remove stuff. You can put, so there's an acronym called CRUD, Create, Retrieve, Update, and Destroy. And for any data structure, we'll use it in the context of databases eventually, but for data structures, that means that you should be able to put stuff in, you should be able to retrieve stuff, you should be able to remove stuff, you should be able to replace stuff, right? So far, I have put stuff in, I've taken stuff out. How do I retrieve things? Get the ith element, or say the 1th element, right? So int x is equal to numbers.get something at index 1, system.out.println. At this point, what is the 2nd element? 20, because at index 1, we get 20, and so we can pull that out. If you want to, you can iterate over these, just like we did with an array. For int y in the collection numbers, right? Then I can say system.out.println y, right? So remember that I didn't take 20 out, I just retrieved it. So I'm still going to get 10, 20, and 30, and 40, right? Okay? But that's how you can put stuff in, take stuff out, retrieve stuff. How do you replace stuff? It's not very useful because replacing stuff is just taking it out and then putting something new back in. But you can replace stuff. What is it? Replace? Nope. What is it? Dot. I forget what it is. Anyway, once you forget what something is, all you have to do is read the documentation, scroll through this, find what you're looking for. There's a remove, here, size tells you how big it is. Sort, we'll talk about sorting later on. We won't get into splitterators or anything like that, but contains, clear, that's going to be remove everything all at once. You have dozens of methods that you can use on your list. Can you do that with an array? Absolutely not. Right? You're writing your own code to do all this stuff. So don't use arrays. They suck. We're going to use lists. Right? We'll pick it up there on Wednesday next week.